Okay, hello everyone. Today I will explain project. Let's first look at the project one. Run the program. You can see the program runs successfully. Now let's look at the code. At the top, we import two libraries. We use Hug for the event list, and we use random to create random arrival time and service time. Next, we set the simulation time. Here it is 1000. We also define two event types. One is arrival and one is departure. Now we come to the main class. This class controls the whole simulation. The clock starts from 0 and create an empty event list. Also create an empty queue. And the survey is not busy. Then we set the arrival rate, service rate, and the containers. Next, we create the first event. Then we put it into the event list. The scheduler gets the next event, then it updates the clock. Finally, it runs the correct event. Now let's look at the arrival event. First, we create the next arrival. Then we check the survey. If the survey is free, survey starts, and if not, the task waits in the queue. And finally, we add one to the container. Next is the departure event. First, we add one to the container. Then we check the queue. If there is another task, survey starts again. Otherwise, the survey becomes idle. Here we create the arrival time and the service time. At the bottom, we create the simulation. Then we create the first event. Next, the program runs 1000 events. And finally, the program calls the result function. So let's look at the project 2. You can see. First, we import the random library. This library is used to generate random numbers. And next, the program prints a title. It tells us this example uses the exponential distribution. Then the program runs 100 times. Each loop generates one random value. And inside the loop, the program generates one exponential random number. Then it prints the value on the screen. Then the parameter keeps all numbers on the same line. So this program shows how to generate exponential random numbers. Okay, next. You can see the program finished successfully and shows the graph. First, we import three libraries. Hug manages events. Random generates random numbers, and this draws the graph. Next, we define two event types and the simulation size. The program will process 100,000 events. We prepare 10 different traffic loads from 10 to 100. This class contains all functions used in the MM1Q simulation. The constructor initializes the clock, event list, and the queue, service schedules, rates, and containers. This function creates the first arrival event and inserts it into the queue. This scheduler always selects the earliest event. It calls either the arrival function or the departure function. This function generates exponential arrival time and service time. So when a packet arrives, the next arrival is scheduled. If the survey is free, survey starts immediately, and otherwise the packet waits in the queue. When survey finishes, the packet leaves the system. If another packet is waiting, it starts survey immediately. Otherwise, the survey becomes idle. The program calculates throughput, average delay, and survey utilization. Finally, the program draws the survey utilization graph. And the program repeats the simulation for every load and finally displays the graph. So this graph simulates an MM1 queue and shows the survey utilization under different traffic loads. Okay, next. You can see. We import two libraries, random generates random number, and this draws the graph. Okay, here we set a fixed random seed. This helps produce the same random screens every time. Next, we create two empty lists. One stores the index and the other stores the random values. And the loop runs 100 times. This function creates a random number between 0 and 1. The program saves the index and the random value into the list. Finally, the program draws a scatter graph and displays the results. So this program generates random numbers and displays them as a scatter graph. You can see. We import the required libraries. This function generates random numbers using the LCG method. And these values are the parameters used by the LCG algorithm. The loop runs 1000 times. And this is the main LCG formula. It creates the next random value. This converts the value to a number between 0 and 1. The program stores the values for drawing the graph. Finally, the program draws the scatter graph and displays the result. So this program uses the LCG algorithm to generate random numbers. Now let's look at the project 6. You can see the program prints the results successfully. First, we import the numpy library, and we define the parameters used by the generator. The loop runs many times to generate random values, and this line calculates the next random number using the formula. The value is converted to a number between 0 and 1. And finally, the program prints the result. This program generates random value using numpy. Now let's look at the last project. First, we import 3 libraries. Hugh manages the event list, and random generates random numbers, and this draws the throughput graph. Next, we define the event types, the simulation size, and the traffic loads. This class controls the MM1Q simulation. The constructor initializes the clock, event list, queue, service status, arrival rate, service rate, and containers. It all starts 2 independent random generators. These functions create the first event, and schedule the next event, and generate the arrival time and service time. So when a packet arrivals, the next arrival is scheduled. If the service is free, service starts immediately, and otherwise the packet waits in the queue. So when service is finished, the packet leaves the system. If another packet is waiting, it starts service immediately, and otherwise the service becomes idle. So this function calculates the throughput, then it prints the throughput for the current load. Here, the program creates two independent random generators. One is used for packet arrivals, and the other is used for packet service. And finally, the program runs the simulation for every traffic load. After all simulation finish, it draws the throughput graph. So this program uses two independent random streams to simulate an MM1 queue and compare throughput under different traffic loads. So that's all. Thank you for your watching.